Hello everyone, welcome back to Code Studio, and in this video we'll be discussing the problem that appeared in yesterday's contest, Codeforces Round 644 Div.3. The question we are discussing is the B question, Honest Coach. So just get a glimpse of this question that is in front of you, pause the video to read the question or else go to the question given in the description below. These are the sample test case input and output given to us. What exactly is given in the question is, you will be given a list of numbers which are actually the strength of players that are calculated, and you have to split that athletes into two teams such that the maximum strength in team A minus the minimum strength in team B must be as minimum as possible. Since we have to calculate the minimum difference between two numbers, we will actually loop across the array and then find the minimum difference between any of the two given numbers. Then we can manipulate the other numbers so as to fit into the teams respectively. Let us analyze the test case number 1, that is 3, 2, 1, 6, 4. This is the input given in test case number 1 and we have to return the minimum difference. To calculate the minimum difference between any of the two given numbers, first let us sort all these given numbers. After sorting, we will be getting 1, 2, 3, 4 and 6. Here, the minimum difference between numbers is 1. When we calculate the minimum difference of any of the two consecutive numbers, the minimum difference of all those differences would be 1. Why did we sort those numbers? Is the first question that might come to your mind. We have sorted these numbers because we will be getting the minimum difference easily. When we calculate the difference between two numbers after sorting, and it is more likely that they are consecutive numbers or differ by a very small number because they are sorted, right? So if they are consecutive numbers, then the difference would be 1, which would be the minimum if there are no same numbers, and if both numbers are same, then the minimum difference would be 0. That is the reason we have sorted the numbers to get an easy calculation of the minimum difference, because we cannot calculate all the possible combinations to find the minimum difference. When we sort the array, then we can actually go on in a single loop and calculate the consecutive difference, and the minimum of all would be the minimum possible difference. Let us assume the minimum difference arises from the two pairs 1 and 2. That is, the maximum in team A would be 1 and the minimum in team B would be 2. So how will we separate? We'll be separating the teams in this way. In the first team, we'll place only one player, that is the player having strength 1, and in the team B we'll have the rest players where the minimum strength in team B would be 2 and maximum would be 1. Here the difference would be 1. Let us also analyze another example. The given strengths are 2, 1, 3, 2, 4, 3. As we have discussed in the earlier example, first let us sort them. After sorting, when we calculate the difference between consecutive numbers and analyze them, the minimum difference possible would be 0. Hence, we will split the teams in such a way that any of the two numbers causing those minimum difference are in opposite teams and they form the maximum and minimum of that particular teams. So let us assume 2 and 2 to be our counterparts, and we'll separate the teams in this way. The 2 will be in first team and the rest would be in another team, where 2 in the first team would be the maximum and 2 in the second team would be the minimum. Hence, the difference between them would be 0. In the same way, we can calculate the minimum difference and solve the problem. So let us summarize the process. First, we have to input all this stuff, then sort the given array, and then find the minimum difference. This is as easy as possible. But here comes an important thing that I wanted to convey to all of you. There are actually two ways to calculate minimum difference, and both of them will actually cross the Codeforces edge, which I have already tried earlier before actually telling you this thing. But both of them takes different times. Okay, the first approach takes a little longer time than the second approach, which actually accounts for somewhere between 15 to 16 milliseconds. Fine. So the low one here shows the first approach where it takes 46 milliseconds, and the above one takes 31 milliseconds. So actually what caused this difference, and both of them pass, so how to optimize our code and all we'll be discussing in this video. This is not only about solving the problem but also discussing how to actually tackle a problem given in Codeforces contest and how to improve our coding skills from contest to contest. So in the approach number 1, I'll be declaring an array named diff and having n-1 numbers, because I'll be calculating the difference between consecutive numbers. So if there are n numbers in the array, I'll be getting the consecutive differences to be n-1. Fine. Then I will store all the differences of consecutive numbers into this diff array. Then I'll sort the diff array so that I'll get my minimum difference to be at the starting, and then I'll print the div.0. That would be my first element in the div array. This will be leading to the minimum difference between any two numbers. Fine. The first process is completely fine because I'll get a correct answer, and then I'll also pass through the given test cases in the given limit. It takes 46 milliseconds, but the limit is 2 seconds, so definitely I'll cross the Codeforces judge. So it's completely fine, and the memory limit is also 256 MB, and we can easily manage that. But there is also an optimal way to solve this problem. Okay. So instead of this, I'll be declaring an integer named mindiff, and I'll initialize it to a very large number that can be fitted in an integer variable. Fine. And then in the consequent loop which I'll be running through, I'll be comparing the minimum value calculated so far and the difference between consecutive numbers, and in each looping step I'll assign the minimum value to our variable mindiff. After the loop, I'll be printing the minimum difference variable, which would be actually the minimum difference possible. You can understand how is this possible by actually analyzing the process. What we are doing is completely fine. Instead of sorting the array, we are actually finding the minimum every time and storing in the value when we are looping through the array. So how does approach 2 differ a lot with approach 1, and how does that actually optimizes our problem is what we'll be discussing now. So let us compare the two approaches. In the approach number 1, I have declared an array which takes a lot more space than the integer which I have declared in approach 2. So approach 2 gets a plus mark there, and then I'll be doing a loop to find the differences, right? That would be same in both of them, so no points to none of them, so 0 0. In approach 1, after the for loop, I'm again sorting the array which takes around n log n time, but in approach 2, I'm just finding the minimum difference inside the loop itself, right? So it doesn't take a much time, and this actually shows why approach number 1 takes a longer time than approach 2 and also consumes a lot of memory than approach 2. Let us say in approach 1 we have n equal to 1000, then we have to declare an array of 1000 minus 1, around 999 limit array. But in approach 2, I'll declare only a single array for any given value of n. On the whole, this is better, and we can get a better optimized solution using approach number 2. It is always better to actually code for in the first approach when you get it while doing a contest, but just make sure that it just does not cross your limits, the cap limits, of course, because during a contest, it is a time consuming method to actually think for another approach when you actually don't get an idea. But after the contest, you can look on different people's solutions and learn from their coding style how to optimize a given problem. Frankly speaking, there can be a better approach than what we have discussed now, and we can learn from that method how to optimize our approach. So this is a continuous learning process, and there is nothing wrong in observing others' code. We can get to see how people think and apply their coding skills and imbibe their skills into ourselves. Observing them, we can improve our coding skills and perform better in the next coming contests. So we have discussed how to go about our problem. So let's go to our code editor and code for the approach number 2, which we have finalized for. So let us include the standard stuff. Actually, coding for the given problem that we have discussed is not really hard because we have already finalized our process, and coding for it doesn't take a lot of time. So first let us input the test cases and then start our main test cases loop. So for a given test case, they'll be giving a value of n, and let us input that value. And then they'll be giving an array of numbers, a list of n numbers. So let me declare an array of n, and then I'll be starting my loop wherein we'll input the array numbers. After completing the input, the first thing we have to do is sorting the array. So to sort the array, we'll include another header file, that is algorithm, where standard algorithms are already pre-written there in the library and we have to use them. So sorting an array is pretty simple. We have to write down sort, ARR is the array, and actually we have to write down the first starting address and the ending address. The starting address corresponds to address ARR, and then the ending address of the array is array plus n. Fine. After sorting the array, as we have discussed, we'll be following approach number 2, wherein we'll be declaring an integer 𝗲. That is what we have finalized on. Let us actually initialize this 𝗲 with a pretty long number. So after initializing 𝗲 with such a long number, so since we are calculating the minimum difference, I will be starting the I variable from I equal to 1, because I equal to 0 case would be satisfied with I equal to 1 case, when array of I minus array of I minus 1 would be array of 1 minus array of 0. So there's no need to actually account for array of I equal to 0 case, because when we include I equal to 0 case, then we have to also account for array of -1 variable. So array of -1 index, that's not possible. So I less than n, I plus plus, and then we have to assign our 𝗲 variable to minimum value of 𝗲, that is the minimum difference we have calculated so far, and the array of I minus array of I minus 1, that would be the consecutive difference, obviously. So the consecutive difference and the minimum difference calculated so far are compared, and the minimum value of both are assigned to the minimum difference. So minimum difference variable is actually being updated for a better minimum value, the least minimum value possible, right? So let's just print the minimum diff with an end line, of course. So we're done with the code. So let's open our terminal and get our app running. Let's copy the test cases here, and since I have already compiled my code, let me run it and check. So my answers are 1, 0, 2, 999 and 50. So my code is working perfectly fine. Let me go and submit our code. Yes, our code got accepted. I don't know why it's showing 62 milliseconds, but it actually showed me 31 milliseconds when I actually coded for in the morning with the same approach. So never mind. So this is how you actually code for a problem. Thank you. I'll be coming up with another very interesting video soon on Code Studio. So stay tuned. Until then, bye bye. Signing off, Sai Ankit, Code Studio.